Tolga, Zafer. I live in London as well. I have been teaching in Istanbul for 12 years in Istanbul Bilgi University, and I've been teaching composition and theory over there. Uh, uh, this whole idea had just started like around 2008, that when I first started teaching over there, and that was about like when I was teaching theory, that it was kind of hard to describe certain fundamental things, and which led me to get into more and more into the circle of fifths, and it took like a couple years. Well, it took like 14 years, and I'm still actually going on. That uh, uh, today's presentation is going to have two sides. One side is just about the concept of it, and the other part is just more technical. Uh, uh, involves involves MaxMSP. So let me actually just start already. Uh, I hope that you do see the screen in here.
Yes, we can see your screen. Yeah.
Okay, good. Uh, uh, so let me actually start a little bit of the technical part of it. Uh, 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 the main thing that I have been working on is actually this module, the scale module. The scale module works this way, that you do have MIDI income, like from up, if you want to think about it, and it actually changes the pitches according to your settings, and it comes out from there. And it's very handy, actually, if you would like to change the harmony of it, if you would like to stick into the harmony in some sense. But there are certain limitations. The first limitation is just it's very static. So you do have this one, and the only way that you can change things is just clicking on things, or you can put another scale in there. But if you have, let's say, like 30, 40 tracks, and you want to change all of them at once, that it's going to be a little bit painful, if you would imagine that. So my idea is just using a dynamic pitch mapping. So this is static. I come up with an idea of this, which I'm going to actually show that later. But this allows you to change things like okay. I mean, you cannot see that. Well, let me do that in here. Okay. Now I need to open this first. Yeah, something like this, that you can change the scale object on the fly, basically. And this idea had just helped me to actually change everything on the way. You can see that in here the transpose is changing, actually, in here as well. Stick one module in there into the mid track, and it communicates in the whole live set. So when you change something, it changes in the entire set, basically. I came up with something. Well, actually, let me show that to you. That I have made. I have started this max patch sets like around 2017, when my son was born, and from that point on, like for the last 4 years that I have been working on it, it is still not completely ready, but it came to a point that it is working, at least that I can say that. So I had made like some couple of it, like this one. It's a little patch that speaks with this. Then after that turns into this one that you can change from here. That at the end, that I really like the idea of just of just making simple everything, it turns into this. This is the scalar module of it. What it does is this, like I can actually show it to you from here. Can you see that? You probably cannot see the color ones good just because of the light in here, but I mean here is the colored ones right there. So this is my center basically, and right now it's on D Dorian. But if I change to something else, like let's say the Ionian, D major, or like the Phrygian, or if I would like to change the center, this allows me, let me get back actually in here for now. This allows me to actually change the tonality on the way that it helps me to play push, like without, you know, like pushing buttons inside of it to change the layout of it. That the layout is fixed, the pads are fixed, but actually tonality underneath is just keep changing like this. So this is one part of it. Like I can actually play something to you just as a case scenario. Something like, for example, an orchestral piece, something like this. It changes. So what you have heard is actually like this many channels in here, like it's around like 16 channels or something like that, and each of them has this instance in there. It's just it's better to put this one as the last instance before the MIDI is actually completed, so you can actually change stuff before then. And before you get into the sound module, that you will have that you regulate the harmony inside of it. This allows you to change the tonality on the way. Let me actually play one more time. So this allows me to actually change the tonality of the piece on the fly. That let's say the case scenario like that you're writing a film music that you would like to try some other modes with it, some other scales with it. So you can do that with one click right now. This is a thing that I have been working on actually that since 2008. This is actually the circle of fifth that with couple extra components on it, which is that you have this component, which I'm not going to get into details right now, but if you would like to know that I have written a book about it, and I can just provide you the PDF if you would like to. Later that I'm just going to write my email that you can get in touch with me about this. So there are 7 modes: Lydian, Ionian, Mixolydian, Dorian, Aeolian, Phrygian, and Locrian. These are the 7 natural modes, and we have been using for the last 300 that we have been using Ionian as major, and Aeolian as a natural minor. But actually that we do have 7 different modes, and we do have the tone center in here that we can change the tone center from here. And also, we do have a slider in here. That slider is just like having this Ionian scales, like have the same characteristics of the Ionian mode. There are total like over 300 scales in there that you can try something else. Let me actually show that to you. This is I like this one. This is one part that you can change the tonality, you can change the tone center, and you can choose in between 300 different modes. This is one part. Then after that, I have written one more module, which is actually producing chords. So let me actually play that some to you. It's me. Do you hear it well? I don't know, but this is just a piano sound. And let me actually show to you what I'm playing. That I'm just playing one note at a time. And let me get into Dorian. This allows me to actually produce all these chords with just one note, basically. It used the proper voice leading that the algorithm inside of it is ridiculously simple. I should say that, but it took like 7 or 8 notebooks for me to just manually write everything and just make sure that it's working. They can find that in the book as well. I mean, just the algorithm. So I do have something to change the tonality. So this is dynamic pitch mapping in the first level. On the second level, after I made this chord module, I put one extra layer of it for dynamic pitch mapping. So think about it this way, that when you have a C major chord, right? I mean, C, E, G. When you have a C major chord, actually, there are 3 notes in there. They are all placed in different modalities, if you think about it. Like the C is on the C Ionian, E is on the E Phrygian, and G is on the G Mixolydian type of thing. So when you start like getting into details in there, that all the notes of the chords are actually on different specific region and in different specific modality on the same time. So when I have the chords like this, that I can apply this idea to the clips as well. So I do have soprano in here, I do have alto, I do have tenor, and I do have the bass. So if I played it again, and this time that I'm just gonna actually play some chords in there as well, that you will hear that these are gonna change. These are, by the way, it's only like 2 measure long loops. Okay, so it's just like keep playing the same thing basically. Okay, that's good. So I don't know that if you can hear the difference, like how the tonality evolves in the music. I mean, these are, again, I'm telling you, these are only like 2 measure long static MIDI clips, and by playing chords, that I actually change their scale object constantly according to the scale. So with only like 2 measure long of loops, that you can actually use different type of tonalities, different type of harmonic structures in the music. That means, like, if you would like to put a piece of music that sounds good, but after that, what if it's going to sound like if I put like some blues progression in there, or like what if I put like some Beatles song in there, or what if I put like Beethoven Moonlight Sonata chord structure with it. So you can actually extract the harmonic structure of one piece and apply to your song in this case. I can actually give you one more example the same way, but this time not with the symphony orchestra. Let's use something else. I'm sorry that I'm not that good on the electronic part of it that well, but I mean, bear with me. Or let's do. Sorry, let me change this. So in that sense, just like if I have a MIDI clip only 2 measures long, 1 measure long, like very static clip, that I can actually get this clip inside tonality, adjust into the tonality. I have then after that put some couple more things in there. Then you can see that in here, D and symmetry, two little knobs for, like, if you would like to get some MIDI clips from the internet, let's say, okay, and some MIDI clips are like in one tonality and the other one is some other tonality, so you can actually change it. First of all, set the initial tonality of that. Like, let's say that I would like to use Michael Jackson's beat bass MIDI. Then after that, Mozart I don't know, something else. Just that you can use all of them and collect all of them into one tonality, basically. The other thing that I have done afterwards, since I'm dealing with MIDI, that I just came with an idea of just why not that I'm doing something for the audio. So I had started with Resonator, and I had written a small patch for that, and you can actually change tonality of. Oh, this doesn't work. Sorry. There's an initialization problem. Let me do it very quick. It's in here. Okay. If I do this again, that's gonna work. This one, take this one out. Should be working now. Yeah, as you see that these are already connected to Tritonet, and you can change it according to tonality. So that means that if I have a drum sound or any kind of audio sound, that I can actually inject the tonality inside of it. So let me try to give a little bit of example. I'm going to start with something in here. Let me actually get the symphony to stop. Anything that I'm using. So I can inject the tonality into the audio as well in this case. It's good to actually, if you would like to use this one for your kick sound, that you can tune it into the tonality, and if you change it, it changes with you at the same time. Overall, this is what it is. What I have been doing that for the last 4 years, actually. Yeah. I don't know if that was enough, but I tried to keep it short.
Fantastic. Thank you very much. Really exciting, interesting stuff. But it's almost kind of like being able to sort of spontaneously conduct the virtual orchestra.
Yeah, and it's like using the harmony as a separate, independent part of the music, that you can use it, and you can inject like any kind of harmonic structure into your piece, basically. In this case.
Being able to do it kind of like globally.
Yeah.
The whole set is like really well. Being able to have massive control over tonality, I can imagine that being a great way to improvise, explore things. So yeah, fantastic. Anyone got any questions, or want to ping them in the chat, or just unmute? Feeling you're waving.
Yeah, hello, Tolga. Could you maybe just very, very briefly and basically explain what object in Max you used to do maybe the core of the algorithm? I've done a similar thing myself with the ZL lookup.
Okay.
I used sort of like rules about the intervallic structure to choose whether it's Aeolian or Phrygian. So did you do a similar thing with that object, or did you use a different object in Max?
Actually, that I have a library that preparing that library took for a while, because that library contains the name of scale, of course. Then after that, how many notes in the scale, because there you have 7-note scales, you have 5-note scales, you know, like up till 12. Then after that, the intervallic structure, and then after that also the position on the tritonet, like which component stays how. The thing that I like this is just like the instead of using well, actually let me go back in here just to show it to you. Just to go to all those menus, that I am just using basically 3 parameters in here. One is for the tonal center in here. The other one is the mode, and the other one is just derivatives of this mode. And it actually goes inside of that list. Basically, I have done one other version of it of tritonet, which you can actually make your own scales as well with it, and it's quite fun to do that. But it is it's a standalone version, and when I tried to put it into Ableton Live, that the structure didn't go well with Ableton yet. So I'm just still trying to actually convert into the to Ableton world, that one. So yeah, I mean, it go well. Actually, I'm quite ashamed to show that, but if you would like to see the inside of it a little bit, that I can try to show it. That it's kind of the opposite of this house. This house is quite tidy because we have a 4-year-old in the house, but patch is quite messy actually inside of it. And since I have been working on this like for 4 years, that it takes for a while to open it at the same time. But basically, what I was using is just one list. That list just like holds all the information, and I'm just calling from that list, basically, with this 3 parameters. And it's unfreezing. Yeah, should be out already. Yeah, something like this. That I mean, it might look. So this is the part that it actually gets the chord, and it calculates the recent scale and send it to bass and tenor and alto and soprano from there. And the mode library, I think, is in here somewhere, if I can find it. Should be in here, yes. This is the one.
So yeah, you're using a very large max call object, aren't you?
Yes,
Yeah.
yes, call object, exactly. That's what I'm doing actually. Yes, you're right. And from that point on, that it just goes and changes everything, like sends the information to the other modules, that scale module, and from there that you can actually control the live set. The other thing that I have done actually, it also sends OSC messages. So if you create a network, and if you're playing with like some other people, if they put that MIDI module into their set as well, when you change it, it changes, and the entire environment on the other computers as well. So you can always make sure that you can play on the like together. And one thing maybe that I should show that to you is this. Like I have shown that to you before on push. What I do is this. We have been taught in the school as like C, D, E, F, G, A, B, C, right? I mean C major scale that we have shown, that we have seen that. But actually there is one secret, not that secret actually, it's obvious, it's in front of our eyes, but when you look at D, where's D? Yeah, right there. That's D. And if you start thinking about everything on D Dorian instead of C Ionian, everything is so symmetric. So the notes, the white notes are in the tonality in this case, and the black notes are out of tonality. So when I actually change tonality in there, all the time D is my center. So I can play actually just thinking about the symmetry. I don't have to think about anything else. In fact, that I don't even have to know how to play keyboard at the same time. I can just think about the symmetry, and I go around, I make my music, and I know that whenever I come to D, that I'm going to come to the center of the tonality, the gravity center of the tonality in that case. This idea is just like helping me to just use the white notes to play, no matter which mode that I'm playing. It's always center is D. And if I would like to play a little bit of like out of scale, I just go to those black ones in that case. Does it make sense what I'm saying? I don't know, but
yeah, I like the fact you got some negative harmony features because that's super trendy, isn't it? At the moment with Jake and Collier.
Yes.
Another thing I wanted to mention, guys. I know it's maybe not totally associated to Max, but you ever heard of a piece of software called Synfire by Cognitone? It uses machine learning to suggest composition ideas. It's really clever. It's quite expensive. But the idea is you can do a composition and it can suggest parts for you.
Yes, I know. Yeah.
It looks awesome, you know.
It's a very nice one. Well, this one doesn't suggest you the MIDI clips. I mean, that you're doing your own MIDI clips. That it just regulates the harmony for you. So no matter what you do, that it's your own creation. So it just helps you to put everything into one tonality in this case. But Cognitone is actually creating MIDI clips for you as well. As far as I know, it was like that. So yeah, I am still working on this, and I have been trying to actually get in touch with Ableton before, but I guess I couldn't explain what I am doing really. So hopefully that what I would like to do is just actually get this one as the native part of Ableton. So you can everybody can use that maybe on Ableton 12 if possible. Any questions? Anything? Thank you.
Yeah, thank you. I have to make a confession. I didn't know that the Dorian mode was symmetrical until about 5 minutes ago.
Yes, it is.
I was just like, I pulled out my keyboard as well, and I was looking at it. I was like, oh yeah. And like, it's the same both ways.
Yes, exactly.
And now I feel like I don't know music anymore.
I mean, we are all getting educated by the Ionian mode, but there are actually 7 different modes, and the most balanced mode is actually Dorian, and the most balanced note is D. So D Dorian is actually the center of symmetry.
I never thought about it like that before. That's really interesting. Yeah, fantastic. Well, yeah, I guess we'll wrap it up there then. Fantastic presentation. Thank you very much.
Thank you. Thank you.
Yeah, so I think we'll move on then to Umut.
So hello, everybody. Thank you for being here. Thank you for having me in here. So I will do this little presentation. I will try to keep it to 20-something minutes, hopefully, where I will introduce you to this cool patch that I have done, talk a bit about my work, and kind of go into this patch, talk about how I created it. So first of all, let me introduce myself. So I'm Umut Eldem. I am currently Belgium-based composer, musician, pianist, keyboard player, and academic. I am currently halfway through my PhD at the Royal Conservatory of Antwerp, and I also teach a course of Max MSP there at the Conservatory of Antwerp, geared towards musicians, beginners in coding and patching, etc., a bit of audio-visual design for those people. And I do my PhD on the phenomenon of synesthesia. And you might know what synesthesia is. Basically, it is a phenomenon where people either associate or experience colors with other senses, right? For example, someone with synesthesia might have colors for the days of the week, notes, chords, chord types, scales. I think our one and only Ned Rush has that kind of synesthesia, for example. And if you go even more intense, some people have very intense synesthesia where they see these colors or see visions as a reaction to music, right? And very rarely you even have cases where people look at something and they start hearing certain kinds of sounds. So I'm investigating that as a part of my PhD to kind of apply this to the contemporary musical performance, analysis, creation, teaching, etc. So how does this relate to this patch? So this patch right here is what I like to call, let's see, an audiovisual fractal soundscape explorer / generator. It does not have a, it's a working title. It can be a bit simpler, but the point is, in this patch, you can kind of move around, you can zoom in. And when you start zooming in, you start hearing these soundscapes appearing. Now, I am very happy to be presenting this, but I'm not happy to be presenting this on this month because I'm on my backup Mac right now, which means I cannot show this in action while sharing this on Zoom. So instead, I'm going to show you a video of this working with the soundscape. And I'm going to be very quiet while it's playing because the audio is probably going to be very quiet. So let's see. Okay, so that's pretty much what it is. So what is going on is this is all real time, right? I'm controlling the fractal with my keyboard, moving with the arrow key, zooming in with W, zooming out with S, rotating it with Q and D. And let's say every X amount of frames, whatever is on the screen is getting analyzed according to, well, I can connect it to my PhD here, a certain algorithm for analyzing colors and the balance of colors. That's going to make a bit more sense maybe in 10 minutes or so. And the results are fed into 5 different granular synths, all have different buffers loaded inside them, which decides what kind of sounds are being played, which results in, well, this nice soundscape. Of course, I use a bit of sonic makeup. If we go down here, you know, I add some phaser, of course, my favorite reverb, Valhalla reverb, to make it sound a bit nicer. And then we have the sound output. I find this really cool because one, the analysis, again, as we are going to see, is really tied with our cognition, as in what are we seeing? What is the balance of colors? How many of them are bordering other colors versus emptiness, etc. Which means what you are seeing is literally what you are getting, right? And I also like it because it's really interactive. So it really invites people to play around with it. I have recently received a commission to make a web-based version of this, kind of porting the shaders and the you know, the audio codes to web audio and web GLSL. It's been a bit of a headache, but it's working. But ended up being really cool. So I kind of want to walk through this patch with you. I'm not going to explain everything because that's going to take 3 hours and you're all going to have a headache by the end probably. But I just want to talk about, let's say, 3 tiny chapters, 3 steps to make this possible in Max MSP. Right, so the first step is getting this Mandelbrot fractal on the screen, right? Using a shader, putting it on the screen, making it interactive. Oh, and forgot to mention, of course, if you press spacebar, you kind of reset all these settings. So you zoom back out. Anyway, the first step is visualizing this. The second step is analyzing whatever is on the screen, right? That's also the fun part. And the third part is doing something with that data, sonification, taking the visual data, turning it into something that is, for us humans with functioning ears, meaningful. Okay, so I have a few tabs here. They're all different subpatches. So to begin with, okay, I have my jit.world that is sending out all the banks. I also have these parameters here, right? The X position, the Y position, the depth that is adjusted with the screen ratio, and they're packed into this message and they're sent to my Mandelbrot shader. Let me open a quick parenthesis here. If you don't know what a fractal is or what a Mandelbrot set is, maybe you saw these cool videos on YouTube where it's continuously zooming in. It is practically a mathematical formula when visualized in a certain way, creates these endless self-repeating patterns with a theoretical depth of infinity. And if you color them according to a certain logic, they make these really cool visuals appear, right? Okay, so what I did was I, of course, used a shader and I used JIT GL Pix. This patch was also my entrance into the world of Jenna, and I was really trying to master that. All right, so what I did was I put in a JIT GL texture and I put it through this JIT GL Pix, which kind of spits out the Mandelbrot shader visualization at that frame with those specific parameters. If I double click into it, you'll see the scary code box number 1. I'm not going to go into detail what's going on in here, but this code is mainly taken from the work of, let's see, the Art of Code YouTube channel. It's a fantastic channel if you're into GLSL coding, that really crazy mathematical stuff. I don't even understand 90% of it. It's great, but I did understand this and I wanted to implement it on my own on JIT GL Pix. Right, and what matters is this output. So I'm putting in all these pixels, I'm giving it these parameters. So it's at this X position, this Y position, at this rotation, at this depth. So give me my Mandelbrot, right, and it spits out this information. I also use this color palette to color this, and I use 5 main colors, all created by JIT BFG. And I use JIT BFG here because if I'm rotating around, you'll see that the color palette is kind of shifting. So you can keep exploring this and, you know, start getting different color combinations. And of course, after I get my nice texture, I use JIT GL video plane to put it on the screen here. So it's very, very easy, very simple. I mean, even the code, I kind of took it from someone else, adapted it. So this is the easy part, right? Okay, so I've done this, and now comes the part of analysis. So what do we do with this data? And that is what I am basing my research on, as I've said. So I'm really curious about how we can take something visual and meaningfully turn it into something oral or something musical, if you want to call it that, or vice versa. We take something with sound and we visualize it in a way that makes sense for us. And my motto is this: less focus on mathematics or mathematical equivalencies and more focus on cognition, as in the main question should be, what are we noticing here? If we are looking at this frame right now with that greenish color and that purple color, and there's like other Mandelbrot set here, what does the human cognition notice? Right, and I kind of boiled down this question to, well, not really boiled down, maybe boiled it up to two other questions. So what is the balance of color here? You know, we have 5 colors. How much of color 1 is in here? How much of color 2 is in here? And 3 and 4 and 5. And the second question, how many different kinds of color profiles are there? As in, if I'm bordering this shape, I hope you can see my mouse as I'm explaining this, how many pixels are bordering this, implying that there is this vast emptiness? How many of them are bordering their own friends, meaning there's a blob of color, we are perceiving the colors together? How many of them are bordering other colors? How many of them are mishmash of a bunch of colors together? These are all tied to how we perceive these things. And I've done something cool, and I have written my own shader to analyze this on the GPU, right? So what, for the analysis part, what I do is I take this resulting texture, the Mandelbrot set, I downsample it, I downscale it so, you know, my GPU doesn't burst in flames, and I send it through another JIT GL pix. And again, scary code box number 2 here. I'm not going to explain all of this for now, but once again, the point is this final line, right? I'm like analyzing it, I'm looking at the neighbors, and I'm sending out this vector with 2 important values for each pixel, final color and the neighbor. And here I use this code, let's say this coding language, to kind of denote which color and which neighbor state each downscaled pixel has. So let's say the final color, if V had an empty cell, this would be 0, meaning don't bother with this, this is an empty cell. If it's color 1, it's 0.1. If it's color 2, 0.2, 3, 4, 5. And then for the, let's try to zoom out of this. There we go. For the this so the neighbor states, I again did the same thing. If it's bordering emptiness, it can be 0.1. If it has the same neighbors, implying an area of colors, it can be 0.2. If it has different neighbors, it could be 0.3. And if it is a color gradient, meaning that it has some neighbors that are the same color, but then also some neighbors that are of a different color, it would be 0.4. So if we have 5 colors, we have 4 possibilities, 5 times 4, voila, it's 20 possibilities you can get with this analysis, 20 unique piece of data. And I also did the second outlet of JIT-GLPix, a different output to kind of visualize what is going on, what it is analyzing, kind of the computer vision, if you will. And you'll see that it's red here, meaning that these are the borders that are being detected. And as I am zooming in, you'll see that these green colors are appearing, which denotes the mishmash, the mixed colors. There are a bunch of colors here. I'm having trouble making sense of exactly what is going on. And as we keep going, you'll see these orange colors pop in, which means that it's a gradient. It's going from one color to the next. And if we keep on going even further, these blue colors are going to pop up, which again denotes the same color, an area containing the exact same color. Right, so this is all done on the GPU with a shader, which helped me immensely to save processing power because, I wanted to do some cool audio stuff with the data. So I did not want to use this CPU LS. But then it is time to bring things into the CPU land by using async read. So now this has turned into a jitter matrix. Again, I am downscaling it because, like I said, it's a backup Mac. What is it going to do? Is it going to analyze all these pixels on the CPU? It's simply not possible. So we lose some precision, but the spirit is there. The results are consistent with what we are seeing. And then I go into JITGen. And again, once again, a scary code box. But the point is, I'm kind of taking all of this information and I'm putting it on the first 20 cells. So the first cell, X coordinate 0, Y coordinate 0, tells me how many of these pixels are color 1, state 1, right? The second cell, how many are color 1, state 2? the next one, how many are color 1 state 3, color 1 state 4, the one after that color 2 state 1. So I'm kind of packing all of this data in a matrix that's actually 20 cells long. I've kind of did my analysis, compiled my data, I've sliced it up using JIT sub matrix, and then I've put it in yet another JIT matrix that I've called colors. So again, what do we get? We get the values of all combinations of pixel colors and states, and also the color composition of the current frame. And for that, I've used yet another JIT-gen, yet another scary code box that ignores the neighbor positions and just gets 6 cells, as in how much of this is color number 1, 2, 3, 4, 5, and empty space. Keep in mind, these are all normalized results of these analyses, right? They're all between 0 and 1, meaning if I added all of these together, I would get 1. And if, if all of the screen is a very specific color at a very specific state, so if I did like this crazy zoom in that is just one color, the result of this analysis would be just this specific state 1, all the rest 0. So that's basically the analysis. I've used a metro here to kind of send out the results of this analysis, so it doesn't happen on every cell, but once every milliseconds, once every second, if it's too extensive, too intensive for the computer. And now the fun part comes. What do we do with this data, right? I have all this cool data. I have these cool fractals. I'm analyzing them. I'm getting the color. I'm getting if they're bordering something or not, the states with the neighbors. Now it's time to create some nice grains. And for this, I use this little patch I call my Hanging Gardens of Babylon, or my Maximus B pachinko machine, as I'm going to explain it in a second. So this subpatch receives the result of this analysis, right? And it first spreads the result in this little pachinko machine. I'm going to explain that. And after that, it triggers a bunch of banks. Here is by default 150. This gets adjusted by how many colors are on the screen total. And all of these banks turn into a random value between 0 and 1. And then they go through a ride on this pachinko machine. So what is this pachinko machine? So as I've said, all of these values go from 0 to 1, right? And if we add everything together, we get 1. So what I do is I get the results, each individual state. There are 20 possible different kinds of data. And I kind of give them a place in this range between 0 and 1, right? Let's see, there's a lot of a certain kind of pixel, so it's going to have a huge range in the scale of 0 to 1. Maybe the others would have a bit less. And if there's a lot of empty space at the end, that would have a huge area in the space between 0 and 1. So what happens? We send a bunch of pachinko balls in the form of random values between 0 and 1. And depending on these chances, they fall through one of these outlets. Color for alone, color for border, color for different, color for full. So all of the states have a different chance of triggering depending on what is on the screen. The best way that I can explain that. All right, so, and then we get to actually generating the grain. So like this color processing subpatches, that was that Hanging Garden, oh God, what is going on subpatch, and sending all of this data to these different granular color 1, 2, 3, 4, and 5 subpatches. In retrospect, I will probably combine these into a one big granular synth patch with a bunch of buffers loaded in. But right now, this is what is going on. So let's say there is a grain, that came in, it went through the pachinko machine and it said, okay, I'm going to be color 1 and I'm going to be color 1 border grain, right? So it comes through here. It's delayed by a certain amount, so we don't get this wall of grains at once and they're kind of spread over time. And then their parameters are specified. Again, I'm not going to go super deep into this, but let's say each kind of grain for a specific color's specific state has a default setting. So we are generating a random grain in a granular synth, and we are pushing it in a specific way to match with that color's profile. So there's a bit of randomization in there, but each state still has a specific sound profile. And these are all sent to these different multi-channel SIGs, and this multi-channel click is going to send the impulse to this granular synth I have written in MC Gen. I also like this patch because I think when I shared it on Facebook, I called it my Gen trifecta because it has JitGL Pix, it has JitGen, even as MC Gen, which was the first time I was really going in depth with these kinds of things. So yeah, so this is a Gen patch containing a granular synth. I'm not going to explain everything, but from the first input, we get the impulse, which triggers, resets this counter. We get our buffer containing the sound the grain is going to belong to. It is read, and after the first repeat by these complicated series of checks, if it has played once, it is turned off, so we don't hear it again. So this ensures that there is one grain playing from this channel, and it does not repeat itself until it has received yet another impulse signal coming inside the Gen patcher. All right, so we have the sound, which goes down, mix down, unpack. I'm kind of taking the sound, making it, possible to do it by stereo. I send a nice phaser. I use a nice Max for Life phaser here. I'm probably going to be writing my own pretty soon. I make sure there is no clipping, nothing wacky is going on. I put it through some reverb for that nice sound field action, and finally it is out. And this happens pretty fast. So if we are at, let's say, 30 frames per second, and again, really apologies for not being able to show this in real time, you do get a pretty reactive soundscape coming out. To control this, I have my main controls here. So here you can, if you want, you can look at the different states of each colors, each version, and you can kind of change the default parameters. So each of these 20 possibilities, each 20 possibilities a grain can have, you can change it here. If you want, you can see the color makeup. Again, normalized between 0 and 1. So we can see, for example, if I'm going back to beginning, if I'm turning around a bit, so 94% of this is empty. This is going down as I'm zooming in. Right, we can see the second color is becoming more and more. Analysis is picking up that color more and more. If we are going in, the third color is in, the fourth color is in. So we kind of get this data on how much of each color is there in the current frame. And that also affects how many grains are sent through my pachinko machine, because if everything is filled and each random chance is going to trigger a grain, it's not going to sound very good. Your CPU won't be very happy. So again, to iterate, I really like what I've done here, and I'm kind of improving this as I go along. This is absolutely not the final version, but it's really cool because the analysis for me is really based on cognition. It's really based on my understanding of synesthesia, which provides an interactive experience, a truly synesthetic cross-modal interactive experience to the user. And I am preparing a web-based version of this. I'm kind of preparing these audiovisual performances that make use of this in real time. So yeah, I hope you have found this interesting. I hope you found this a bit inspiring. And yeah, thank you all for listening to me.
Okay, thank you. Yeah, has anyone got any questions or any? Pop it in the chat, or
yeah, I've not been able to look at the chat, so let me see.
Feel free to unmute your mic if you want to ask a question directly.
I guess everything is very clear then. I saw that Aaron commented that the Fractal was a great choice, and I agree. I mean, that was kind of the starting point. And I was in fact inspired by there is this YouTube video, I think it was Sounds of the Mandelbrot set, which I really liked, and a friend of me challenged me to make something like that. And while I really loved it, I found it a bit lacking, as it was literally the mathematics of Mandelbrot set used as an oscillator, which created something really cool. But I wanted to see if I could kind of, see our vision of this fractal and make something cool with it. But I would enjoy, I will absolutely try, just putting in my webcam feed, for example, and see what kind of soundscapes can come out. And Ronald, yeah, I have considered using other fractals. I mean, the thing is, I'm not very good at math. I have a classical education. Maybe Tolga will know I'm from the Mimar Sinan State Conservatory, so we don't learn about fractals and Mass Effects MSP soundscapes there. But I will be exploring, maybe changing to, let's say, the burning ship fractal, if you know that there are different kinds of fractals, maybe adding in another shader to visually do something with this analysis as well. So there is a lot to do here.
There's a few interesting fractal components in Touch Designer, Umut, on the free installation. There's a Julia and a Mandelbrot. And maybe you might be able to reverse engineer some of the maths into MSP. I was actually used them a few weeks ago to play with a few things. They're quite fun.
Oh yeah, I'd absolutely like to check it out. I mean, as much as I'm not very great with maths, I love this because it's literally just this one formula. It just fits into this one line and creates these awesome shapes. Like that's what I absolutely love about that. And Aaron, yeah, the webcam might absolutely be cool going handheld with a webcam, so I can kind of move around and do something psychedelic, kind of get reactions out of people. Because as I've said, that's what my research is all about, right? I mean, I want to take something visual and see if I can create something sonically interesting in function of that.
So could you tell us a bit more about maybe some of your other future plans for this? You did touch on ideas of more integration, but what do you see this patch looking like in 5 years?
Well, hopefully not in the garbage bin. That's my first up, and I'm creating this kind of stuff. So let's see what I would like to do with this. So the first step is optimization. This is horribly unoptimized. Like, let's say, let me go into my analysis shader, for example. Let me zoom out a bit. Now, if you are good with shaders, if statements, big no-no. If you do if statements, if you chain if statements together, your GPU is going to cry. It's going to be very sad. It's not going to work as fast as it should. So it should be possible to kind of boil these down into a mathematical formula or an expression that would give the same numerical result I want, which should increase performance. Right, that's one thing. The same thing with my granular synths, right? I realized after making it, why am I using 5 different synths? They're literally the exact same thing using 5 different buffers. I can have one synth, 5 buffers, and each grain can read from one or the other depending on this other inlet. So optimization is one thing. A few more features could be cool. For example, how cool would panning be? We could also look, if the shapes are to the left or to the right, we could have some spatialization. We could have 4 speakers, 8 speakers, something crazy going on. And then, maybe we can kind of project this onto a big wall. We can have a bit more user interaction instead of using the keyboard. What if people could literally move around in the Mandelbrot set at a 3D space? So that's the thing with this kind of patch, you never run out of ideas. The near plans, like I've said, for Gaudium's Screen Dive, I've been commissioned a web-based version of this. It has been very easy to port. I mean, there have been a few problems, but it's actually works. So I will be able to send you a link to that in about a month, so you can experience and kind of have this little trippy soundscape experience on your own. But I also want to integrate this into performance, right? Like, let's say I have my keyboard here and I'm playing something, and what I'm playing directs the movement of this fractal. Or maybe I can have this fractal moving around on its own, right? Let's say I have these set points, interesting sightseeing designations, like at this coordinate, at this depth, at this location, and it's going from one to the other depending on what I'm playing. I'm also kind of planning / composing a performance like this for end September, begin October. Right. Andrew says it looks like you have opened the possibility of doing a very similar thing, but in the opposite direction. Instead of turning it into performance into video, you could turn a live video into a performance. Yeah, absolutely. Why not? Why not? And could also be interesting to kind of stream this, like to have this interactive stream where, if you have seen Twitch plays Pokemon, for example, that a Twitch chat kind of plays video games and they bump into walls constantly. And we could have this input from the viewers, or just the webcams of the viewers, that bunch of people pointing their cameras at the stuff. like I said, I mean, it's really easy to think of cool things to do with these kinds of patches. Hopefully in 5 years, there will be a lot of variations of this and you will all be able to enjoy it. And yes, Tolga, the dancing, absolutely. That's that's a given.
Okay, well, if we've no more questions, then I guess we'll wrap it up there. Thank you very much.